Hello, Math 125 students. In this video, I just want to talk through the test prep and say a few things about exam one study tips. I'm not going to do this for every exam, but since quite a few are asking me about how to prepare for the exam, and I also have noticed quite a few haven't looked at the test prep, I thought I'd say a few things. So I'm going to talk through the test prep. Again, the test prep is participation, so don't forget to open it up and enter something. I know I'm giving answers away here, but since the test prep is just for practice, I wanted to get this out for the weekend. So when you're thinking about preparing for an exam in this course, I don't want to sugarcoat it. It's going to be challenging. The exams are challenging in this course. So you want to fight for every piece of credit you can get. And there's a lot of ways you can get credit. We do give partial credit. So what you can't do is say, I don't know how to do this problem at all. So I've talked a lot about giving some advice in class and about how you can fight for as many points as you can. But the first thing is you gotta know the homework. If I ask a question that's identical to the homework, you would want to know how to start it. So you gotta have to pan through the homework, and then you should review all the topics, and I have a lot of stuff to kind of help you with that. And you should make a note sheet when you're doing that. And I hope the test prep I made is at least getting you to think about the test. And then you should practice all the exams. And there's two ways to do that. And I will talk a little bit about how to practice recognition so you can gain some confidence. And then you should work through some exams in detail. Okay? In class, I talked about how, it's just good if you're going to cram one night, you might as well do it a few nights in advance because then you have more time to think about it. I will review the day before the test. It'll be kind of an open review with the discussion. I'll bring a bunch of old exams and we'll go from there. But in terms of studying, first and foremost, you should know the homework. So let's just pull something up here. We'll do this view. So you can go to past assignments, you can see the work, you can see your test prep. You should glance through them. I'm just saying a quick glance. You don't have to work through every problem again. But say, okay, I'm going to take 10 minutes, I'm going to scan through the homework, and I'm going to see if there's questions that I would be really upset if Dr. Lovelace asked them. And then say, do I know how to start them? Do I know how to start each problem if it was on a test? Would I be able to write something down if I was asked this same question? So try to make a little note of the things there. Don't spend a lot of time there. I find sometimes people they'll study something for 3 hours and it wasn't a key thing. And so I like to just make sure you've seen, go through and look at all this stuff. Okay, so let's see you've done that. Then I would go through and see if any of these things are helpful to you, any of these review sheets, if you want to practice choosing dx and dy. That's why I have this stuff here. If you want to look at 6-3 review, I do have an actual reviews here where I talk through, hey, here's the rules. I'm not picky about final answers, but do simplify standard value, well-known values of well-known functions. And then I have a quick review of topics. You just want to go, okay, do I know how to do Riemann sums? If he says, and I don't like to ask more than 2 or 3 or 4 subdivisions, but would you be able to do it? And typically when I ask it, I say you don't even have to simplify. You just have to write out all the numbers in all their places and stop. And I'll say those instructions on the test. Could you solve for constants given when you're doing antiderivatives? Can you use the fundamental theorem of calculus part 1 and part 2? Can you do net change and total change? Total change was the stuff with absolute values. Can you deal with distance and velocity acceleration? Can you do substitution? Can you do the area between curves? And the new one we've been doing is volumes. And volumes are all about putting the right things in the right places. In a lot of ways, this first test in this course is much easier than the future tests. Now, so for some students, that will be discouraging to hear because they may say, oh, I've already been struggling. But we haven't gotten to the heart of the integration techniques. And there's a bunch of stuff that comes together there. And because of that, there's more content on exam 2. So this unfortunately sets up a bad situation where sometimes exam 1's kind of easier or people get a little bit higher scores and they feel like they're doing well and then they stumble on the next test. Hopefully that does not happen for you. But I think the number of topics that may seem like a lot, but I think there's a lot of things you're going to know how to do right away when you're preparing for this test. Okay, so let's actually just look here, and I have a more detailed review on there as well. So I'd like to just look at the test prep. I feel bad because I feel like the test prep is not a good indicator for this test, but I just wanted you to do something where you had one submission. I wanted to put you on the spot. I do think this is easier some of these questions. I just couldn't find good questions, and I didn't want to make it too cumbersome for this first one. For future test preps, the questions would be a little more involved. But just think of this as a quick initial test. I mean, you really need to be doing well on something like this. These are my numbers. But the whole point was, hey, I just wanted you to ask yourself the question, if you got this on the test, would you be able to immediately start? Step one, could you integrate? And I hope that that's becoming faster. You don't want to get hung up on these little things on the test. You want those things to be automatic. So it should be x to the 3/2, and you want to be good at this and not have these things hang you up, as I said. And those cancel, and then you have your function x plus 2x to the 3/2. And my point of the test prep was just to force you to do this kind of under a tiny bit of time pressure. This isn't a great example, but at least made you work a little bit. And then you say, okay, now I'm going to plug in a 9, and it needs to be 67. So you put, that implies that when I put a 9 here, this already makes you face a few challenges. You're like, if this was on a test, would I be distracted by the fact that it looks like they're messy numbers? Would I be able to use my calculator? So that's why I want you to use the test prep. It's just a chance to do mechanics. And I will tend to ask you mechanical questions on the test prep. So square root of 9 is 3 cubed. That makes this 27. It's 67. I'm doing this on the fly. If you find an error in this, apologies. This would be minus 9, minus, I think that's 54. So that's going to be minus 63. So C is 4. And so then you might say this plus 4. And then practice checking your work. What if this was on a test? Could you be sure you're right in one step? So put a 9 here. Put a 9 here. And then you would say, okay, 9 plus the square root of 9 plus 54 plus 4. Is that indeed 67? Yes. Okay, now I know I'm right. I could hand this test in and know with 100% certainty I'm right. That's the stuff I want you practicing on the test prep. Okay, also time yourself. How long did that take you? Was it 5 minutes? Was it 10 minutes? A problem like that should take no more than 3 to 5 minutes. You want that to be fast. Okay, it should be less than that. So you need to keep practicing. This one looks messy. The moment you see this, it's substitution. You need to pick something for you. We talked a bit about things you should pick. Pick something that's on the inside of something whose derivative is on the outside. So to me, the obvious choice is this. Some of you might have thought to pick the entire denominator because you said, well, I thought you said to pick the denominator. But the problem with that is the derivative of this is going to be really messy. So that would not be my first choice. If you did the derivative of this, it's going to be 2, 9 minus e to the x to the 1 times negative e to the x. Already I'm like, I don't want to try that. That's messy. Let's get rid of that. So go with what's on the inside and what's simpler, and then see what happens. This is the derivative is this. And then I see, oh yeah, this is going to work well. 1 over negative e to the x du equals dx. And then the whole point of this was this. So this just needs to be automatic. This one, right away you were doing antiderivative, same thing. There should not be thinking during this. Sometimes I see students that are just staring at the page. It just might be they're worried or something. But we really should be able to go. So then this is negative the integral of u to the negative 2 du. And this is hopefully a chance to catch these little things. The power should go up, divide by that, plus c. And so I'm ending up with 1 over u plus c. So it's going to be 1 over 9 minus e to the x plus c. And you can check your work by taking the derivative and see if that's what you get. Okay, so there's that one. Quite a few people have that. So again, time yourself. How long did that take you? Every page of the test, we have 80 minutes for 5 pages. Every page of the test needs to take you definitely under 15 minutes, but under 12 minutes usually what I say. So that means, and mostly something like this would typically be a third or half of a page. So you really need this to take you under 4 or 5 minutes. I'm just saying, I'm being conservative, so you have lots of time to check your work. Okay, this one. Some people are just confused by the idea here that x is a dummy variable. You know, if I say, what's the integral from 0 to 1 of x to the 5th dx, and then someone else comes along and does the integral from 0 to 1 of u to the 5th dx, and then someone else comes along and does the integral from 0 to 1 of t to the 5th dt. Sorry, the second one I meant to say du. Fix that there. These are all the same number. Sometimes we say it's just a number, it's an area, it's the same function, it doesn't matter which dummy variable you use. So the comment I like to make here is, if we know this is true, then we also know this is true. Even if we don't know what the function is, they're telling us that when you integrate this function from 0 to 81, you're going to get 8. The area is 8 for this function from 0 to 81. It doesn't matter what the dummy variable is. The reason I say that is that's going to come up later in the problem. So the rest of the problem was, what in the world does this have to do with this? Well, it looks like substitution. You get du is 2x dx. You get x dx is, I'm just playing around with different ways of doing this, is this. And then the whole point of this was it was forcing you to change everything but the squiggle. 0 becomes 0. 9 becomes 81. Aha, now it's starting to appear. And then I'm going to cancel that x, and it's going to end up being f of u. Okay, I see it. 1/2 du. I'm going to pull out that 1/2. It's going to go from 0 to 81. And I think this is where people were confused, the ones that have already emailed me about this. At this moment, what you see is that this right here is saying the area under the f function from 0 to 81. That is actually the same as this. It doesn't matter that it's a u. It's the same sort of story, that all of these are the same. Okay, so they told me that was 8. This was 8. And so the answer was 1/2 times 8. It's not that I love this question, but it forces you to change everything and show an understanding. So you had to say, okay, I know that's 8. Half of 8 is 4. Done. Okay, I hope that makes sense for the test prep. I thought I would finish this by saying, okay, that we want that to be easy. I would say those are really on the far easy side of what you're often going to see on tests. I want to warn you. But I think everything on a test you should know how to start. So here's a totally random old exam. The game I'm about to play, you can play yourself. You can go to my exam archive and I would click on several random old exams. I wouldn't start with the honors exams. We don't offer the honors calculus anymore. But you can see I have a ton. My exams are, a little more formulaic because I just have so many. I mean, if you looked at mine, I'm not going to surprise you with any topics. But let's say you clicked on a few. And I did. I clicked on one. I did click on it at random. So this is just nothing. So what I'd like you to do when you're doing this quick recognition studying, which is what we're about to do, is ask yourself, how do I start the question? Don't get hung up on the details now. And I'd like you to go through 3 or 4 exams in about 10 minutes. And then at the end of it, go back and look at what your notes were and see which ones you got stuck at starting and which ones you did. And in doing this, you can recognize, all right, I know how I can get lots of credit. I know how I can be efficient. I know how even if I'm running out of time, I can show a bunch of understanding. Let's play the game. Okay, so here's our first one. Pretend that you're in the exam. What are you going to do first? This is all about simplifying. So first thing you would do, let me get a better color here so you can see it. Just immediately you're going to be integrating. But there's little challenges here. Like, would you know that this is 5/2 times 1 over x and that comes from the log? Would you know that you can rewrite this as 3 over x to the 3/2? Would you know that this last one actually requires substitution? Would you know that if you use substitution here, it doesn't have to affect the other things? In fact, if it was me, I would think of this as 4 separate problems. And when we grade, that's kind of how we grade, is if you mess up, you're missing, we're looking at, did they do this part right? Did they do that part right? You can split things up. Okay, but I hope you saw that you would just immediately start integrating here. Okay, but it's nice to put yourself in the exam. You do u equals this. Okay, I've already spent enough time. So when you're doing this quick recognition, it's no more than 10-15 seconds a problem, and then you move on. Don't finish them. Say, okay, I kind of know how I would start that one. It's a simplification problem that we have to show if we know the rules. Next one, absolute values. So then you go, how am I going to start an absolute value problem? And this is something, if you prepare, you should immediately know how you're going to start. It shouldn't take any time if you're prepared. We did several of these in the homework. It was a topic in our worksheet. So you need to somewhere on your note sheet say, I know that's what I need to do first. It needs to be automatic. We can't have that take us a bunch of time to think about a key concept we've already gone over. Divide by 3, you get 2. I remember when I gave this test, a lot of students didn't know how to solve this. They took the square root of both sides. You have to square both sides. This is 4. And that's the whole point of this question, was to show that you knew that you had to integrate from 0 to 4, and that you have to integrate from 4 to 16, and that you have to split the problem up into 2. And then you had 2 jobs. Now, after you do this little quick recognition exercise, you're going to compute them both. If one of them's negative, you'll make it a positive, you'll add them together. If you don't know the start, you're not going to be able to get anywhere. If you know the start, you're probably going to get most of the points. Okay, so think about that. Could you do that page in 12 minutes? Preferably in under 10 minutes. That'd be a good goal, because if you do every page in under 10 minutes, you'd have 30 minutes left at the end, because it's 5 pages. Okay, so you could review the solution. We're trying to do it quickly, though, so when you're doing this, don't get bogged down. Just say, do I know how to start? Do I know how to start? Your goal here is to find where the holes in your understanding are, and to gain confidence that you know how to recognize problems. Okay, what's this? A messy looking integral. We only have 2 methods right now, which is simplification or substitution. So the very first thing you're going to do is u equals. You should, as soon as you open the page to this exam and see this problem, you know it's u equals is the very first thing you're going to write down. And it's going to be this. And you're going to have du is negative sine of t. So this is going to become the integral. There's going to be a negative when those cancel. So you're just trying to build up, if you aren't there yet, build up these skills. There's going to be a 1 over negative 1 du. And so this is going to be negative the integral of this. And you say, I don't know what that is, but that's secant squared. And so we're done. This was a very fast problem, which is negative. But this is one of those where if you didn't prepare and do this quick recognition, I could see a student getting here and going, I don't know how to do that. It looks weird. But someone who's prepared goes, okay, the only methods we have are simplification and substitution, so we've got to do substitution. The moment I write down u equals, the rest of the problem flows from it. Okay, that's what you're trying to do during this part of studying. Okay, I see another integral. It looks terrible. Substitution. You should pick u to be something on the inside or the denominator. I think both work, actually. So when I see that, I go du. And we haven't had this come up that much in class. It's nice to know the derivative of the square root by memory. But if you don't, you can write this, but it always ends up being 1 over 2 root x dx. Now there's going to be a negative because there was a negative there. So if I flip it to the other side, it's 2 root x du equals dx. The bounds become, if you put in a 1 for x, this is a 0. Often on my tests I say, you have, for full credit, you have to change the bound. So, follow my directions if I say that. If I plug in a 4, I get the square root of 2, I get negative 1. I get e to the u. I get the square root of x. I get negative 2 square root of x. That's all here. Du. Success. I get negative 1/3. The integral from 0 to negative 1. And I didn't know how this was going to come out. I can't remember this exam. I don't have the answer in front of me. But to me, when I look at these problems now, okay, and you had to know simplification. I had to know this. To me, those are not math skills. Those are conceptual skills of, did you know when you can counter an integral that can't be simplified to write u equals? So a prepared student would have known the step 1 there. They would have known step 1 here and step 1 here. And just by knowing step 1, you get yourself a lot of points. And I want to get all of you there. Okay, let's keep going. Then we get this question here that's this. So we go, oh, I'm scared it's a notational problem. But then we go, oh, but we did that homework question. We know what to do. This is just about knowing if you can manipulate. So when I look at this question, I go, well, I want to do this. 6 f of x dx plus the integral from 5 to 6 of 10 dx plus this thing. And that one I want to do substitution. I get du. So I haven't even looked at the whole question. I'm just trying to make my initial impressions of what I'm going to do. dt is 1/3 du, which is the integral from 0 to 6 of 1/3 f of u du. Aha. I think I have a few things I can do. I can compute this one. This one's the integral from 0 to 6, so this will be 1/3 times 12. This one I'll have to think about. Why do I know what the area from 5 to 6 is? Well, I know the area from 0 to 6, and I know the area from 0 to 5. So that means the integral from 5 to 6 of f of, it doesn't matter, you can see it doesn't matter what variable I use, of f of x dx is going to have to be 12 minus 4, which was 8. I do remember students did not like this question. This is 10 times 1. That was the answer. But I think you would, if you're prepared, you would have had an idea of how to start. And again, there might be some place on the test you get stuck, you lose a couple points, but you don't want to lose all the points. And you want to get most of the points everywhere else. Okay. Use the right endpoint method. Would you immediately know what to do? Delta x, step 1. 3 minus 1 over 4, which is 2 over 4, which is 1/2. X sub 0 is 1. X sub 1 is 1 plus a half, so 1.5. X sub 2 is 2. X sub 3 is 2.5. X sub 4 is 3. And then the rest of the question is just plugging in. You're doing 4 subdivisions. So if you aren't there yet, we want this to be fast as well. Times the width, which is 1/2, plus the log. And I now say this, which means you don't have to do any computation. You just have to put the numbers in and stop. I try to do things to save you time where I can. There are computational things I will make you do on the test, but something like this, I just want to see that you can put the numbers in the right places. So since we're using right endpoints, know that this is 1.5, know that this is 2, know that this is 2.5, know that this is 3, and then just stop. And when we grade, it actually makes it easier to grade as well because I can just see you knew what you were doing. Another Riemann sum 1. This wouldn't be worth a lot probably, but it's just, can you put all the things in the right places? Delta x is going to be 3, so 2 over n. So it's going to be a 2 over n here. And then the xi is 1 plus 2i over n. So this is log of 2, 1 plus 2i over n. Plus 1, done. But this is, don't spend a lot of time on this. Water balloon thrown, so you would see this and go, I know how to do these problems. I've done a whole bunch of these in my homework. I'm going to go right here. Sometimes on these questions I say, you must show me that you're finding the constants and integrating, which would avoid someone trying to use some other methods. But the whole point is to get the initial condition. So you would know you're searching for initial condition. After 2 seconds, the balloon accidentally hits right next to your math instructor. Your math instructor estimates the balloon hits the ground at a downward. At what height was it thrown? So they're telling you at 2 seconds, it's hitting the ground. And when it hits the ground, the velocity is negative 80. So the rest of the question is plugging these things in and finding those numbers. And it just becomes a big algebra question. You might think about the homework questions. There was one homework question that was a little more challenging because there was a third thing they didn't tell you, in which case it's really good to label that. If it says There's another time when it passes your window. Label that t equals a. And then yes, you have another unknown, but it's very helpful in a problem like that to do that. Okay, let's keep going. All right, an area question. We knew this was coming. I hope at this point you can look at this question and see if you go this way, you're always between this on the left and this on the right, so you want to use y. If you go up and down, that's not what happens, so I would immediately do y. Then you're going to need to know these intersections. So you're going to have to figure out what they are. You need to know the intersection of this with this. Incidentally, things I would do right away is I would write x equals y squared, because I know I'm going to need to anyways, and that might make it even easier to combine these two things, because then I have y squared equals 3y. And these are the things that I find eat up students' time. They'll spend an entire page trying to solve a quadratic equation. That's good to know. You'll learn that when you're going through the details, but that can't happen. We have to be able to do that faster. You should try to factor. And this is the main place you're practicing this is on the homework, because you're doing this in tons of homework questions. So if you're not allowing yourself on the homework to practice this, you're hurting yourself. You have to let yourself struggle and do some of these things on the homework so that when it's time for the test, you can do them quickly there as well. So this is -2. This is 5. And really how you approach the homework has a direct correlation to how you're going to do on the test. You really have to approach that homework well. But these things are actually easy to practice, easy to check your recognition. Find the volume obtained by rotating about the y-axis. So for this question, let's do that here. I would still much rather use y, and the fact that I'm using y forces me into a certain method. I now label this as y, and I have to think about, if I take a particular thing here, that it's a washer. I'm perpendicular to the axis of rotation. The moment I see it's a washer, I'm filling this in. And this is something you really can get fast at if you follow the advice I've been giving this last week. The inner radius is the y squared. The outer radius is the 3y plus 10. And then it has another one going around the vertical line, x equals 25. Okay, so it might be nice to have that picture again. Yep, that picture. And I'm here. Again, don't get bogged down. If you find that problem's taking you too long, just move on. But x equals 10 is x equals 25. I think it's way over here. Let's see. If y is 5, I get 50. No, it's right on that line. So it's right here. I'm rotating around. Okay. And so if you, does it say you have to use shells? It doesn't say anything. So it's just because I don't want to spend too much time here. If I do perpendicular to the axis of rotation, I'm still doing washers. But now I've got to think about this being the inner radius and this being the outer radius. Boom. So the inner radius would be, how far is it from there to there? And this is x equals 25, and this is given by that formula. So there's no way around it. You have to practice this on the homework. This becomes really important, that you can be able to look at a picture like this and say, okay, if from here to here is 25, and from here to here is what we're calling 3y plus 10, then the inner radius is 25 minus 3y plus 10 squared. Done. And then the outer radius, by the same reasoning, if I want to go from here to the outer edge, is going to be 25 minus y squared. Now that's the hard one that you'll have to practice in the homework. There's no replacement for that practice. Okay, what's this question? Fundamental theorem of calculus. Find the speed. So I need to find f prime of x, and hopefully you know that it's this. And this problem reminds you of, all right, did I know that right away? Then I'm going to have to plug in pi. Consider the region under this curve. Here's 1, Here's 9. There's this curve right here. Looks like this. The question says to find a horizontal line that bisects it. Now that should sound familiar because it's directly from homework. It's a hard homework question. Hopefully you would know from doing this homework question, it's the last question in 6-1, that you should work with this region. Now, I think I did it so the numbers come out a little nicer than the homework, but it was a tough homework question. So remember, you have to find the total area. So this is the one that if you hadn't done the homework, this becomes really bad. This is x to the negative 2. This is negative x to the negative 1 from 1 to 9, which is negative 1/9 minus negative 1, which is 8/9. So you're trying to set that something equal to half of that, which is 4/9. And you try to set this up. An easier way to set this up would be to integrate from b to whatever that is, 1. And then you'd have to rearrange this, which comes out to be y to the negative 1/2 minus 1 dy. And then you're trying to solve this. Okay, I spent a little more time there, but you should not spend a lot of time just, can I start this one? Can I start this one? I think we would see as we glance back through that test that most of these things could be immediately started when we saw them. Okay, so it's worth 10, 15 minutes to click through a few, just click through a few other ones, whichever ones you want, and then go, how do I start this? Okay, simplify and integrate. All right, substitution. Okay, substitution. Okay, substitution. Oh, fundamental theorem of calculus. Subdivisions. First thing I do is compute the width. All right, antiderivatives. Okay, we're going to have to integrate, find constants. This is a dropping tomato problem. Okay, here we have a region. We have to find some intersections, and then we're going to need to do a vertical cut to find an area. We're going to do some volumes of revolution. So you can play that game until you can do something, an approximation of what I just did yourself. Okay, hope that helps.